In this video, we're just going to go over some helpful guidelines and reminders for your full design concept for Deliverable 3. If you're watching this in a future year, past 2025, definitely look at the actual Deliverable 3 assignment document for all of the specific requirements you need. And also, if you're watching this in 2025, look at all the requirements on the document. So here you can see I have just a screenshot of my site. I just used Snipping Tool, took a screenshot of it, and I put this into GoodNotes on my iPad. You're welcome to do it this way. You can annotate it on your computer with a mouse directly. You can also do a physical drawing. So this is me just drawing out the site by hand. Pretty rough sketch of what it looks like. You can see it's not totally accurate, but it's also not inaccurate. So we're just going to be doing a rough sketch here. Your dimensions and all of the exact locations don't need to be exact for this. So don't worry about trying to do a perfect drawing if you are doing it by hand on pencil and paper. So this is what my site looks like. Highly encourage you guys to use color, as I did here, for your design. It's going to help you a lot in terms of communicating your design, but you're not required to use color. Just know that any amount of color you use will help with clarity, and if you don't use color, that's that many more things that you need to label. So some of the requirements we go over, and this is specifically for the OHIL survey area, is the fact that we need a new sidewalk, we need a concrete slab 40 feet by 70 feet, we will need to improve the water quality or the water management in some way, and we're going to have to add a retention pond of at least 900 square feet. And then any optional amenities and all of the scorecard items. The scorecard items, you can see what your scorecard is in Canvas on the assignment. I will show you an example of a scorecard later in this video, but know that it is not going to be your exact scorecard, so do not go off of the one you see in this video. So the first thing I would do when I'm planning out my design is look at what's currently there and what my constraints are. So some constraints that we have are the trees by OHIL, probably good to keep those, but you could remove them if you wanted to. We also have this existing sidewalk, and we know we need to put a new concrete slab here. This is going to function as a covered student space. So anywhere here is a pretty good place to put it, right? Looking at the contour lines, though, we can see that this is a low point, which means water might flow towards here. So it might make more sense to put it on this open area. But another thing you need to consider is this area is widely used. People play spikeball, volleyball, there's movie nights here. So just keep that in mind as you design. Anything you do will change the way the space is used. Some other constraints is we know we're going to need a sidewalk connecting to this sidewalk to wherever our concrete pad is. That means that sidewalk's going to have to go down this hill. If you think about contour lines, your steepest slope is going directly perpendicular to them. So what we don't want to do is put a sidewalk going this way. We could put a set of stairs here, that might work, but we also need a sidewalk for ADA accessibility. So it might need to go along the hill like this, or maybe like this. It's kind of up to you to figure that out. And we're going to go over a tool in Civil 3D here in the second half of this video of how you can explore grading, and we'll go over what that means in a second. So we know we need a slab, we know we need the sidewalk, and we also know we need a retention pond. That retention pond, we kind of mentioned this could be a low point, so maybe we put the retention pond over here. Some of you guys familiar with the area will know that there's that big drainage ditch by the side of the road that is here, so putting the detention pond somewhere close by maybe makes some sense. Lastly, we need to think about all of those additional amenities and scorecard items. These are things like bike racks, LED lights, solar panels, a farm bed, a garden, anything like that that is on the scorecard you need to make space for here. It's best to think about those things now before you go out and do your entire design. So I'm going to get started with a concrete pad. We're going to just roughly sketch it now, but we're going to show you how you can get better sense of dimensions in Civil 3D. So we said 40 feet by 70 feet, so maybe I will just sketch the concrete pad here. 40 feet by 70 feet. Not a circle. I want that to be a square. Not a circle. Wow, it really doesn't like me. Let's see if I can do it this way and then rotate it. Maybe that'll work better. There we go. So I'm going to put my concrete pad there for now. We also know we need a sidewalk from here to the existing sidewalk. So I think a good path would be something like this. That might make some sense. But you can see this is a potential area of high slope or high grade, which we'll talk about here in a second. So that's the part you need to be most careful about. And this works out pretty well because then we could also put maybe a staircase here and then also connect a sidewalk going here, just not through the tree, obviously. Maybe somewhere in between, like that. So that could be a place where we put the sidewalk. If you want to actually show the width of it, you can. Pretty good to think about that. There is a minimum width requirement. In 2025, that width requirement is 6 feet. So just look at what that is in your document. And we also need that retention pond. So maybe I'll come over here and make it here. Like, I don't know exactly how big this is, but this is something we can look at in Civil 3D. So maybe something like that. I could do a big circle, but I don't think that looks good. I think an irregular shape gives it more, makes it look a little bit more natural. So maybe something like that. And just thinking about some of those amenities, I think I'm going to want a garden here for the students. So we'll do a garden, put some plants there, and then solar panels I think would work really well. But we want to make sure those are south facing. That's how they get the most light. So maybe we put the solar panels here. And it can even be used by the garden if they needed to. So I'm just going to label these. Solar panel. And then you would also go through and label this as like a garden, for example. Make sure it's clear to the graders and also, you know, if you're actually making a design, what exactly you're labeling things as. I also think, well, there's a garden there, so maybe it makes sense to put some rain barrels. We have this covered structure here, so obviously water is going to be flowing off. So maybe I'll put rain barrels here, and water from that roof can even collect here. And so this is just an example. You definitely shouldn't be doing it like this exactly, but this is a good example of what a design concept might look like. Just, you want it to be well thought out, and we'll go over some of those other things in Civil 3D, but I want to briefly touch on what exactly BMPs are and what grade is. So BMPs are best management practices. That's included in Deliverable 3, and it's kind of a misnomer for the name, best management practices. What does that mean? The way I like to think about it is BMPs are ways to control water. So any effective water management technique is a BMP. So some examples of BMPs include rain beds, rain gardens, big storage containers. This retention pond will actually be a BMP. Dry swales, wet swales, all of those are examples of BMPs. You're going to learn about these more as you go throughout the class, but know that you need to think about where you're placing those now. So in general, BMPs are best placed wherever water accumulates, so that's going to be the low point of your design. Looking at my design, I already know that I'm going to have water flowing this way, and I already have a detention pond there, which is great. So that means this water is going to accumulate there, it can get filtered, and it'll go into the groundwater, which is good. I also know some water might go this way, right? There's this big ditch here. So maybe it makes sense to put a dry swale or wet swale or a rain garden or something here, right? And do that. And looking at the changes to the surface I'm going to make, well, I'm putting a sidewalk here, and I don't want water to just roll all the way down the sidewalk here and have it pool up here or anything like that. So maybe I'll put in something over here. I don't know what that is going to be yet. But maybe I put something between these sidewalks to prevent erosion, to prevent water from pooling on this lower sidewalk. That way water can also flow off the sidewalk this way if it needs to, and also go that way. So that's an example of how you could design for water and BMPs, and we'll talk more about those in class and in the project for future deliverables. The last thing to go over is what grading means. So one of the requirements is to have your sidewalk be of max grade 5%, the sidewalk, or 8.3% with 5x5 rest paths. So let's explain what that means briefly. So you might be used to seeing, if we're thinking about a triangle, you might be used to seeing a degree symbol, or maybe radians as well, to express a change in elevation, or change in height. In civil engineering, though, we don't really use degrees. Instead, we use slope ratios or percent grades. So to explain both of those, the slope ratio is the easiest one to understand. The slope ratio is just the ratio of rise to run, so this would be y and x, and in its simplest form. So if you had, for example, 12 and 6, that's really a 2-to-1 grade, or 2-to-1 slope. The other way we express grade or elevation change is through percent grade. And the formula for percent grade looks really similar. It's still y over x, but now we multiply by 100%. So just to walk through some examples of what that looks like, here we have 3 triangles. They're all labeled with their length. This is just based off of the square unit in the background, and they also all have their angle measurements. So if we were to look at all of these and do the slope ratio for them, the slope ratio for this first one, rise to run, so that's y over x, is going to be 2 over 8. So this is going to be a 1-to-4 ratio, or 1-to-4 slope. This one, you can look at it here, is 4-to-8, which is equivalent to 1-to-2. And then this one is 8-to-8, which is equivalent to 1-to-1. So we are asking for a max grade of 5%. So let's look at what that could look like as a percentage. Here we know this is a 1-to-4 slope. So let's multiply that by 100%. And this is 25%. This is 1-to-2. So this is going to be 50%. And then this is a 1-to-1 slope. So this is going to be 100%. So a weird thing about percent grade is that a 45-degree angle is actually 100% slope. And anything past this is actually greater than 100% grade. So it's possible for you to be describing things in grades that go above 100%. But eventually, when you hit a straight 90-degree angle, that's going to be a 1 over 0. So you're going to be at an infinite grade, I guess is a way to think about that. So you can see here, we're looking for a max grade of 8% or 5%. So that's even less than this. And that really has a lot to do with ADA accessibility and also pedestrian comfort. It's not comfortable to be walking at a 25% grade or a 1-to-4 grade for such a long time. It gets really taxing on your legs. If you ever are driving up or down a mountain, there'll often be grade signs on the roads, especially for those heavier, larger vehicles like trucks. So on I-64, for example, I think if you go towards the Appalachian Mountains, the grade on the road is like, it's either 4% or 6%. I can't remember, but think about what it looks like driving there, and think about if you had to walk that entire distance. So we're looking for that max grade of 5%, and in the video after this, we'll go over how you can look in Civil 3D to figure out what your grade is.